Thank you very much, Antoinette, and good morning, everyone. Yes, as Antoinette said, my name is Cliff Curtis, and I will be your presenter today on this event entitled Getting Ready to Teach International A-Level Chemistry. This is module 1 of 2 modules. The second one will take place at exactly the same time tomorrow. That is 9 a.m. British summertime. So let's have a look at what it is that we want to try and achieve today. Our aims and objectives of this particular presentation will be to gain an understanding about how this particular qualification is devised, to understand the content of the qualification, to understand the assessment of the qualification and how to cover the content contained within it, to explore how to plan the course, to review the support available from Pearson to enable you to help you to plan this particular course. So the agenda will be a simple introduction to Pearson, a welcome to Pearson, so that you can gain some appreciation of what we are and what our aims are. Then to have a look, as I said, at how the qualification is actually devised and look at the content of it, look at the assessment of it, look at the planning of the course, and then finally the support. So first of all, welcome to Pearson. This is just a little introduction to let you know what we are about. We are the world's leading learning company, and as the UK's largest awarding body, we feel that we are best placed to provide qualifications aligned to the British education system. Our international heritage actually stretches back over 150 years. Today, we partner with schools, universities, and employers worldwide, offering world-class, globally recognized qualifications to over 3.5 million students a year. We are trusted and recognized qualifications partner to 6,500 schools and colleges and employers globally, and we mark over 10 million exam scripts on behalf of the UK Department for Education each year. And we operate in 70 countries worldwide, which is why we feel that we are very well placed to offer qualifications for international candidates. So let's have a look. How is this qualification actually devised? Well, the structure of it is there are 2 separate qualifications available. There's the International AS, which I'm going to abbreviate to IAS, and there is the International A-Level, which is abbreviated to IAL. Both IAS and IAL are modular qualifications. There are 3 units at IAS and a further 3 units at IA2. The 6 units together will make up IAL, as we'll see in a moment. So let's first of all look at IAS individually. This qualification consists of 3 externally assessed units, units 1, 2, and 3. By externally assessed, of course, I mean that it'll be marked by Pearson through their series of their examiners. This can be awarded as a separate IAS qualification, or it can be used and contributed as 50% towards the International A-Level qualification. The International A-Level qualification has 6 externally assessed units. The 3 IAS units, 1, 2, and 3, which I said will make up 50% of the qualification, plus 3 IA2 units, which are units 4, 5, and 6. And together, students wishing to achieve the International A-Level must therefore complete all 6 units and 6 exams in units 1, 2, 3, 4, 5, and 6. The content of the qualification. Here's a little overview of the specification for IAS. In Unit 1, you've got formulae, equations, and amount of substance, atomic structure in the periodic table, bonding and structure, introductory organic chemistry and alkanes and alkenes. Moving over to Unit 2, you've got energetics, intermolecular forces, redox chemistry in groups 1, 2, and 7, an introduction to kinetics and equilibria, organic chemistry, alcohols, halogen of alkanes and spectra, which will be simple mass spectrometry and infrared spectrometry. In the energetics and the kinetics and the equilibria section, there is very limited mathematics. Most of the mathematics will appear in the IA2 units. In Unit 3, students are expected to develop experimental skills and a knowledge of understanding of experimental techniques by carrying out a range of practical experiments and investigations while they study Units 1 and 2. This unit will assess the students' knowledge and understanding of experimental procedures and techniques that were developed in Units 1 and 2. And I will be talking a lot more about Units 3 and Unit 6 in the Module 2 tomorrow. There's quite a number of questions come up or something come up in the chat box. I'm just going to have a quick look to see whether or not there's anything that I need to answer. It looks like it's just people saying good morning. So nothing needs to concern with yet. Okay. Right, so let's move on and have a look at an overview of the IA2 section. So the second section, it needs to be fulfilled in order to get the IAL qualification. Unit 4, kinetics, entropy, and energetics and chemical equilibria and acid-base equilibria. This is where the vast majority of the what I would say will be more demanding mathematical concepts will start to kick in that won't be present in IAS. For example, in kinetics, the Arrhenius equation will be there. In chemical equilibria, we'll be starting dealing with equilibrium constants and the calculations associated with that. In acid-base equilibria, we will be dealing with, obviously, Ka values and pH values and calculations of those. And of course, that involves the use of logarithms. It's obviously more demanding mathematics than you will find in the AAS specification. And then we're pursuing more organic chemistry by looking at carbonyls, carboxylic acids, and looking at chirality. In Unit 5, we've got redox equilibria. And again, we will be starting with some more mathematical concepts here because we will be dealing with, for example, calculations involving electropotentials and using electropotentials to predict the feasibility of chemical reactions. And then we've got transition metals and their compounds, a bit more organic chemistry, arenes, nitrogen compounds, and tying everything together, organic synthesis. So that's where they will have to use all of the organic chemistry that they've learned, both at IAS level and in Units 4 and 5, to bring it all together to deal with a synthesis of a compound. It could be in multi-stages. In Unit 6, students are expected to develop further the experimental skills and knowledge and understanding of experimental techniques that they acquired in Units 1 and 2, specifically the tests for anions and cations, gases, and organic functional groups by carrying out a range of experiments and investigations while they study Units 4 and 5. One of the things that some students don't realise is that particular aspect of the work that they did in Units 1 and 2, i.e. the tests for anions, cations, gases, and organic functional groups, they don't seem to think that that will crop up in Unit 6 and forget to revise it for this particular unit. So that's something that they need to be made aware of. This unit will assess the students' knowledge and understanding of experimental procedures and techniques that were developed in Units 4 and 5. And as I said, I will be doing a lot more with experimental skills in Module 2 tomorrow. Okay, so let's have a look to see how this qualification is actually assessed. There are three papers, paper 1, paper 2, and paper 3. Paper 1 covers unit 1, and it's a 1 hour, 30-minute paper. It's available in January, June, and October, and it's worth 80 marks. And it will be 40% of the total IAS. And therefore, because of course it makes up 50% of IAL, it's effectively 20% of the total of IAL. There are two sections, multiple choice questions and a mixture of short response, open response, and calculations. And again, I will be looking at the question types in much more detail in module 2 tomorrow. So if you can attend tomorrow, we will have a very close look at all of those types of questions. And in fact, I will be having some exercises where I'll be giving the participants the opportunity to mark some student work in all of those particular types of questions, apart from the multi-choice, both short response, open response, and calculations. This paper will include a minimum of 18 marks targeted at mathematics at level 2. Level 2 is a pass grade at GCSE. So that's the type of skills involved. So that would be involved. Level 2, for example, would be rearranging the PV equals nRT equation, given P, V, R, and T in order to calculate N. That would be classified as level 2. If you were substituting directly into delta H equals MC delta T, and you're given MC and delta T to calculate delta H, that would not be classified as level 2 because that is too straightforward a mathematical exercise. There are, of course, some mathematics that go above and beyond level 2 in IAL. Anything that involves things like the Arrhenius equation or logarithms obviously is above level 2. But there must be a minimum of 18 marks targeted in this paper at level 2 or above. And the students will be expected to apply their knowledge and understanding of experimental methods in familiar and unfamiliar contexts. And that's the key thing there. That second, those last two words, unfamiliar context, is very, very important. Students need to be realised that they will not be tested just on things that are actually directly on specification. They will be tested on their ability to apply what they've learned that is on the specification to an unfamiliar situation. Okay, there's unit 2, which remember was energetics, group chemistry, halogenoalkanes and alcohols. The setup is absolutely identical, so I don't need to read through all of that. It's a 1 hour, 30-minute paper. 40% of the IAS and 20% of IAL, and there's the same sort of thing, except there's one extra question type that will be set in paper 2 that's not set in paper 1, and that is, if you look in the middle of the bottom box, section C, contemporary context question. There will be a context question set, which is not set in paper 1. And the best way of you identifying what they mean by contemporary context question is to have a look at past papers for unit 2 and look at section C, and you'll get a good feeling for what the examiners mean by a context question. Okay. So same setup other than that, okay? But do notice right at the very bottom there, this paper may contain some synoptic questions which require knowledge and understanding from Unit 1. Okay, and Unit 3, of course, is all about practical skills. This is 20% of the total of AAS and 10% of the total of IAL. And I've already mentioned that the students are expected to develop their experimental skills from the practical work they do in Units 1 and 2. Okay, no multiple choice questions in this particular paper, but there will be, as in the other two papers, short open response and calculation questions, and there will be a minimum of 6 marks targeted at level 2 or above. Okay, so that's the IAS. Have a look at the IA2. Again, there are 3 papers, one covering Unit 4, rates, equilibrium, further organic, and you'll see that it's an hour and 45-minute paper covering 40% of the total of IA2 and 20% of the total of IAL. And the paper will be made up of multiple choice questions. There will be 20 multiple choice questions. I forgot to mention the number of multiple choice questions on papers 1 and 2. It will be 20. Section B will contain short response, open response calculations and extended writing questions. So that will be questions that are worth 6 marks or above, and they're marked in a particular way. And again, I will be looking at the way in which those extended writing questions are marked in Module 2 tomorrow, okay? This paper will contain questions that require information from the data booklet. See Appendix 9 for that. And notice that this time there will be a minimum of 22 marks targeted at level 2 or above. Okay, there's a large number of questions seem to have cropped up, so I'm going to have a look at those before I look at the other 2 to see, okay, see if there's anything I need to answer. So I'm just scrolling back through these, if you can bear with me. Finally explain this point, as I don't understand 40% of AAS. Right, if students are just sitting the AAS qualification and don't move on to AA2, to do the AA2 to get the full A level, in other words, the only thing they're doing is IAS, then that will count as 40% of the marks for that particular qualification. However, if the students then carry on to do IAL, the mark they get in that paper, paper 1 or paper 2 of the IAS, will count as only 20% of the total international A-level qualification. How can I see the playback of that recorded video? Okay, that recording will be sent to you, I believe. Do you mean the recording of this event? Okay, right. And the PowerPoint is also okay. How can we get the PowerPoint of this event? There is a PDF version in the resources, which Antoinette has mentioned to you. Yeah, access the delegate materials for the PowerPoint. Okay. Anything else? Does the student go on to take all their IEL exams at the same time? No, it's modular, and there are exams set in January, June, and October, so they don't have to sit them at the same time. You can enter them for the exams as in when you feel that they are appropriate. Is it mandatory to students to have clear AAS first? No. If you really wanted, they could sit all 6 exams at the same setting. So they don't have to clear the AAS first, but I think it would be a little bit of overload to make a student sit 6 exams at one particular setting. The virtue and of the module system is that you can spread out when they take the modules over a period of time, and it gives them the opportunity, of course, to do resits. Is that qualification sufficient only to do A levels? Yeah. Yeah, I think you mean to move on to IAL. Yes, I would say that the best thing, if you want to move on to teaching IA2, you must, I would say you have to teach the IAS content first. Okay, right, so I think that's answered all the questions that are in the chat box just at the moment. So let's move on to the rest of this and look at the next section, which is Unit 5 paper. Again, I don't have to read through all of this because everything is the same. It's an hour and 45-minute paper. Its availability in January, June, and October again. 40% of IA2, 20% of IAL. And again, Section A, 20 multiple choice questions. Section B is the same. Section C is a contemporary context question. And again, as I said, the best way of you finding out what the examiners mean by contemporary context question is to look at the past papers that are available on the Pearson website. And you'll get a very good feel very quickly when you've looked at 3 or 4 of them of what they mean by a context question, okay? The data booklet, see Appendix 9, I would very much, I should have said this earlier, I would recommend that you get your students to download the data booklet and print it off and put it into their folder so that they become familiar with it and use it as often as they possibly can. 18 marks targeted at level 2. Okay, and notice the bottom line, the paper may contain some synoptic questions which require knowledge and understanding from units 1, 2, and 4. The students need to be made aware of that. And then the paper 6, the unit 6, practical skills in chemistry part 2, 1 hour 20-minute paper, 20 minutes of the IA, 20% of IA2 and 10% of IAL. Short response, open response calculation questions, no multiple choice here. Okay, and a minimum of 6 marks targeted at level 2 mathematics. And the students will be expected to apply their knowledge and understanding of practical skills to both familiar and unfamiliar situations. And I think the best way of us appreciating what is required for the practical skills will be by looking at these types of questions, which I will do in module 2 tomorrow in great detail. Okay, so if you can attend tomorrow, hopefully I'll be able to give you a much better insight in the requirements of answering the practical skills questions then. Okay, there's one question. Can you provide question bank for IAL? I can't provide a question bank, but if you go to Exam Wizard, which I will be mentioning in the support material that's available to you, there is a huge bank of questions there. Also, all of the past paper questions are present on the, for the International A level are present on the Pearson website. And what you need to do is to open up your search engine and type in Pearson qualifications, and then click on International Advanced Levels. Then click on C, though you get a whole bank of ABCs coming up. Click on C, and then click on Chemistry, and you will be taken to the International A-Level Chemistry web page section, where you can simply download, view or download, if you require, all of the past papers that have been set so far at International A-Level, both International Advanced Level and International A-Level, and including the mark schemes and the examiner's reports, and that's up to and including all of this year's papers. Okay, just let me close up that. I hope that answers that question. Okay, the unit results. So how do we actually get to giving your students their grades? There's no change to the uniform mark scale from the previous qualification. It's identical to the previous qualification. Units 1, 2, 4, and 5 have a maximum of 120 uniform marks. Units 3 and 6 have a maximum of 60 uniform marks. So the raw score marks they get on the papers are converted into uniform mark scales. If you're really interested in how that conversion is taking place, then I suggest you simply Google in your search engine, how are raw marks converted to UMS marks for Pearson exams? And I'm sure you'll be taken to a web page from your search that will explain how that is carried out. Okay, so that's how the grades are awarded. Once the raw score marks are converted to uniform marks and added up, if a candidate manages to get 48 marks, they will get a grade E, and scaled up to 96 marks in order to get to grade A. And for units 3 and 6, there's the grading. Okay, and those marks are then added together to give the final grade for whatever qualification that they are cashing in. Okay, so the qualification results: IAS is a total of 300, IAL is a total of 600, and that's how the grades are given in total for the cash-in. So in order to get a grade A at IAS, you need to get 240 uniform marks. In order to get a grade A at International A level, you need to get 480 of the 600 uniform marks. Okay, 2 questions have just cropped up. Okay, as I said, if you are particularly interested in how the raw marks are converted to uniform marks, I suggest you type in how are uniform raw marks converted to uniform marks for Pearson Edexcel exams into your search engine, and I'm sure you'll be taken to a website that will explain how that is happens. If you can't do that, then the best way to do is to contact the subject officer, whose contact details I will give you at the end of this specification, okay? I do not know how raw marks are converted to uniform marks. It's never interested me in particular, so I've never looked it up. So unfortunately, I can't answer that question. Okay. Okay, each topic and subtopic in the specification contains several specification statements. For example, there's topic 4, Introduction to Organic Chemistry and Alkenes. And you'll see in topic 4A, the introduction, there are 8 specification statements there labeled 4.1, 4.2 up to 4.8. The importance of those specification statements are that is what you have to teach. So when you look at the specification, then the way in which you first go about planning your course is you look at all of those specification statements, because that will tell you what you have to teach. And then, of course, from there, you will go about organizing how you're going to go about teaching this and in which order you're going to teach it. And I'll talk to you a little bit about planning the course a little bit later in this presentation. Okay. There are standard marks to achieve A star in AL. Could you please explain this too? I can't remember the exact way of explaining it. I can't remember how A star is worked out. Again, I will try to find out and mention this tomorrow as how star is worked out. There's no set, I don't think there is a set number, but it's a formula that's worked out. I will try to find that out and mention it tomorrow, okay? Okay, which specification statement is the following question assessing? So if you've got access to the specification, i.e. can you bring up the specification that I put into the resource pack? If you're able to open that up and have a look at it, have a look to see if you can find out. To give you a clue, say if you're going through the whole of the specification content, it is in section 3, topic 3, okay? Topic 3. So I'll give you a little while to see if you can find that. I've actually managed to find that. You will find that it's section 3.22, which is students should be able to use the models in 320 and 321, which is the models of metallic bonding, to interpret simple properties of metals, including electrical conductivity and high melting temperature. Okay, and you notice it says including, so that does not mean that it is only those two, which is why the examiners felt that they could set a question on malleability as well. Okay. There's your second one. This is the question that assesses the specification 910. So 910 specification, just have a think about what that might actually be. Okay, no need to put anything into the chat box. Have a think. What do you think that statement is going to say? Oh, sorry, I don't know how that's happened. It's gone on to slide 3. Go back to slide 2, which has brought up, be able to predict and justify the qualitative effects of changes of temperature, pressure, and concentration on the position of equilibrium in a homogeneous system. Okay, notice that in this specification, as in the international GCSE specification that I was talking about on Monday and Tuesday, there is no reference to Le Chatelier's principle. There is no requirement whatsoever to teach Le Chatelier's principle, and no marks will be awarded in students' answers if they make use of Le Chatelier's principle. So the decision will be made by you as to whether or not you do teach Le Chatelier's principle. I am a great advocate of not teaching Le Chatelier's principle because I think it causes more harm than good. But that is a decision that you must make for your teaching and your students, okay? But I stress there is no requirement for teaching Le Chatelier's principle. If you look very closely at the student book, which will be student book 1, you will find the chapter that I wrote, because I was one of the co-authors of the student book, so you'll find that the chapter that I wrote does not make any reference to Le Chatelier's principle. So if you have a copy of that particular book, then have a look at how I have used, how I have just made a suggestion as to how you could go about teaching this particular topic without making use of Le Chatelier's principle. It's entirely up to you which particular route you take. Okay, activity 3. Okay, and again, don't write anything into the chat box. I mean, there's nearly 60 of you in the room at the moment, and obviously we can't all look at everyone's answer, but think for yourself or jot them down on a piece of paper. What are the essential points to include when answering the following 2 questions? And the reason I'm asking this is because I'm asking you to do this is because it's something that I would like to recommend that you ask your students to do before they start putting pen to paper when they're answering questions that are worth 3 or more marks. Okay, this question, the first one is in 2. It's the second one that's really important. I would say to my students, think about what needs to go into the answer before you start putting pen to paper, so that you don't go down the wrong route and then have to cross out your work and start again. So have a little think about that. What are the essential points to include here in those 2 answers? And then I will put up my suggestions on the next one. Suggestions for part 1, which is drawing the dot and cross diagram, they should show all the bonding pairs, 1 mark, and all the non-bonding pairs on both oxygen and chlorine for the 2nd mark. So I would want my students to be thinking, right, that's what I need to show before they start putting in the relevant dots and crosses. And then the next thing, they need to state the shape of the molecule. Then they need to talk about the regions of bonding electrons repelling one another. And then they need to mention that that repulsion should lead to adoption positions of minimum repulsion, or stating that they need to get as far away from one another as possible. Okay. Okay, there's another thing that's very, very important, and I will be talking about this in much more detail tomorrow, but I briefly want to mention it today, is that there are various assessment objectives also involved in the assessment of your candidates, and they fall into 3 categories. AO1, Assessment Objective 1, which is all about demonstrating knowledge and understanding of science. There is AO2, which is split into 2 sections. Part A is the application of knowledge. Apologies for the O missing. the application of knowledge and understanding of science in familiar and unfamiliar contexts. And part B is the analysis and evaluation of scientific information to make judgments and reach conclusions. And AO3, which is all about experimental skills. And the experimental skills, of course, will be tested in units 3 and unit 6. Okay, right. I've just looked up on my tablet about how to get an A-star grade in Edexcel International A-level. And I will read, to get an A-star Edexcel International A-level, you must score at least 480 uniform marks in your overall international advanced level. And okay, it then doesn't tell me what mark you need to get. Okay, I'll keep looking. Okay. Right, as I said, I will be dealing in much more detail about these assessment objectives tomorrow. In particular, of course, I will give some indication of what the difference is between AO2A and AO2B. I'll do that through showing you a series of questions that are targeted at AO2A and AO2B, and also giving you the opportunity to mark students' answers from this year's papers, May and June papers, that were targeted at AO2A and AO2B. And also I'll do the same for AO3. Okay. Right, so let's have a little look at how perhaps we could go about planning this course. The key document that you need to deliver this course, I think, is pretty obvious: the specification. This document is available on the Pearson Qualifications website. And if you don't know exactly how to get to the Pearson Qualification website, then simply open up your search engine and type in Pearson Qualifications. And then the search will take you, the first search almost certainly will be the required website. And then you simply click on, you scroll down, I think on the left-hand side, and you will see international advanced levels. You click on that, and then a whole series of little boxes come up in the horizontal row, A, B, C, D, E, etc. You click on the box C, and then you will get an opportunity to click on chemistry. And when you click on chemistry, that will take you to the International A-level chemistry website. Okay, and from there, you'll be able to see over on the right-hand side, specification. Okay. It is listed under course materials in the teaching and learning webpage. So it's there, okay? Specification and sample assessments. So that's the first document that you need to download and save onto your computer. Because without that knowledge, of course, you will not know what it is that you need to teach. So how do you make sure that you cover this particular content while others? Obviously, the specification. And then, of course, from the specification, you need to develop, I think, some schemes of work. You need to work out for yourself exactly how you are going to cover this. Now, we have got some guidance of that because there are schemes of work that are present on the website. Again, under that teaching and learning materials section that I brought up on the previous page. Okay, I will go back to the previous page. If you look at the teaching, so can you see teaching and learning materials 41? Under teaching and learning materials, you will find a scheme of work. Now, the scheme of work gives enormous detail. I'll give you an example of the scheme of work in a moment. It's not one that you have to follow. It is just a suggestion to get you started. What you can do, of course, is you can then look at that and then formulate your own scheme of work that's appropriate to your teaching and your students. And I keep emphasizing this because I do not want to come across as someone who is telling you how to go about teaching this, because that would be very arrogant and foolish of me, because I do not know your students. You know your students and you know what is going to be best for them. All I'm going to do is to make some suggestions. Okay, there's a couple of things come up in the chat box at the moment. I am new to the specification and I find it somewhat bulky. How is this specification taught for the proper understanding of students? Does it require using the textbook and dictating notes to students, or using the textbook to explain the main contents of the specification? This is entirely up to you and your teaching style, okay? I myself used my own notes for teaching. I created my own notes for teaching and used those to cover the content, and used the textbooks to supplement the material. I know a number of teachers that actually teach from the textbooks, so they use during their classroom teaching, they actually have the textbooks open and make use of the textbooks during the course of their teaching. So it's entirely up to you as to how you go about this, okay? And lastly, lesson plans. So once you've got your scheme of work, then you may think it's well worthwhile you creating individual lesson plans for any particular section of the scheme of work that you've got, okay? The lesson plan is going to be obviously a detailed description of the course of instruction of a particular lesson. A daily lesson plan would be developed to guide the class learning. Details will obviously vary, again, depending on the preference of you, the subject being covered and the needs of the students. I can't emphasize that too much. It's the needs of your students, obviously, that you need to take into consideration when you're developing your lesson plans, if that's what you feel is very useful. There may be requirements dictated by your school regarding the plan. They may have a pro forma that you have to follow. Okay, so you need to perhaps take that into account. It's, as far as I can see, it's your guide for running a particular lesson, and it includes the goal, i.e. what the students are supposed to learn, how the goal will be reached, the method, the procedure, and a way of measuring how well the goal was reached. I'm going to talk a little bit more about lesson plans a little bit later in the presentation, okay? So that's what I think perhaps the three main things that you need to consider to cover this specification. Okay, that is an example taken from the very first page of the scheme of work that is on the website in those teaching and learning materials. And you can see that it is quite detailed, okay? There is a lot of useful information there. I'm not suggesting that you follow every single bit, but if you're struggling to have some classroom activities or some teaching points or suggested teaching resources, then you could go to the scheme of work and that will give you some suggestions. And then you can pick out from those suggestions, those that you think are going to appropriate and match in with your style of teaching and matching with your learning styles for your students, okay? So, for example, play a spot the difference game with cards showing all the key definitions may not be something that you think is appropriate for your students. So you may think, oh, I'm not going to do that, okay? But there are some suggestions for you. That's all I can say. So have a look at the scheme of work and pick out from it what you think are useful, okay? Is the scheme of work available on the Pearson website? Yes, you remember the teaching and learning materials section of the International A-Level specification. It's in there. That's where the scheme of work is. Okay, so yes, it's available on the Pearson website. Okay, so I said I will talk a little bit more about the contents of a lesson plan. Now, the first point I need to make here is this is not a Pearson recommended format. Okay, These are just some suggestions from me. This is the sort of thing that I used to do when I made a lesson plan for me, knowing what I felt was useful to me as a teacher, and would be useful for me delivering it to my students. Okay, so there are many formats, and most lesson plans contain some or all of these elements, typically in this order. The first thing, of course, is the title. What is it that you are teaching on that particular lesson? So it could be rates of reaction, changes in concentration, changes in temperature. How change in concentration, change in temperature affect the rate of reaction. And what you could do for the title is you could simply copy the specification statements. The time required to complete the lesson, well, that will be dictated, of course, by your timetable. It is dictated to you by your school or centre. Okay. The list of required materials. The required materials could be any worksheets that you're going to hand out during the course of that lesson. It could be details of chemicals and equipment that are required if you're going to do some practical work during that lesson. It could be, for example, if you are doing shapes of molecules, it may be that you want to have your model kits. They could be molly-mod kits. So you've got that down listed in your requirement and materials. Anything that you need in order to carry out that lesson effectively. And if you've got those list of materials, of course, particularly with regard to chemicals and equipment, and you're lucky enough to have a laboratory technician, then you can pass over that list of materials to the laboratory technician, and they will make sure, of course, that the required materials are present and ready for you. So it's a good way of being prepared for the lesson. Okay. And then I think probably the most important of everything, a list of objectives for that particular lesson. What are you expecting the student to know by the time you get to the end of the lesson? What is he or she expected to know? If you have got no idea about what you expect them to know, then of course you have got no idea about how, you've got no plan about how you're going to achieve that. So I think it's very, very important to have it clear in your mind about what you are expecting for your students to know by the time you get to the end of that lesson. I do emphasize expected because, of course, they may not actually know everything that you would want them to know by the time you get to the end of the lesson. And I'll come back to that in a moment, okay? Then you might like to consider a lead into the lesson that focuses the students on the lesson skills or concepts. This could include showing pictures or models, or asking leading questions, or reviewing previous lessons. I'm sure that all of you who have been teaching for a while will know, well, you've all learned chemistry, otherwise you wouldn't be teaching it. You know that chemistry is very much a scaffolding process. You lay down, I often refer to it as like building a house. Before you can start building the walls of the house, you need to lay down foundations. And then you start building the first floor of the house, and then you build up that gradually, and then you put in the second floor, and then you start building up the second floor, and then you put in the roof, etc. And teaching chemistry is very much like that. And I must admit that when I first started teaching, I was really not that well aware of the requirement and the necessity to review previous lessons when I was teaching new topics. And I got frustrated that my candidates and my students were not picking up on what I was teaching them. And I thought, I'm doing a really good lesson here, and somehow they're not learning what they need to learn. And it's not until I went to one of my more experienced colleagues and said, you know, I'm not doing as well as I thought I was doing here. What is the problem? And he talked me through a particular lesson. He said, tell me how you've gone about teaching this. And he said, well, did you actually talk to them about this before you started teaching this? And I said, no, well, I taught them that a month ago. And he said, well, if you'd have done a revision of that before you started teaching this, just a quick revision, I think that they would have realized what skills and what knowledge they needed to have at their fingertips to be able to use to develop the new skills. And I thought, yes, quite right. So sometimes reviewing previous lessons may well be very, very useful before you get stuck into the new subject content. So it's something for you perhaps to give some thought to. Okay. Now, once you've got to that particular stage, then of course you need an instructional component that describes the sequence of events that make up the lesson. So put that in a nutshell, that includes how you're going to go about teaching this particular topic. What's your instructional input? And where appropriate, guided practice by the students that can consolidate new skills and ideas. I'm a great believer in trying to give some guided practice during the lesson and not leaving it just to homework after the lesson. Now, this guided practice could be in the form of questions that you ask them. It could be in the form of the verbal questions, which you get them to answer verbally. It could be in the form of some questions that you put onto worksheets that you hand out to them. It could be trying to get them to work in little groups to answer specific questions, and then getting a volunteer from that group to come up and talk to the rest of the group to give an answer, the answer they come up with. So giving them the opportunity to explain to the rest of the group their understanding of this. The good idea behind this, of course, is that you can then quickly see whether or not they've grasped the concepts that you were hoping that they grasp. And if they haven't, it gives you immediate feedback. It gives you the opportunity to say, right, you haven't quite grasped this. Let's go over that again before we move on. Okay, so opportunities to do that during the course of the lesson, I think, could well be very, very useful, but I'll leave that up to you. There are time constraints I do appreciate, okay? All right. So independent of practice that allows the student to extend skills and knowledge on their own. And again, that could be in the form of a test that you give them. It could be in the form of homework questions that you give them, but something that gives them opportunity to extend their knowledge or skills. Now, this could be the opportunity where you could take the knowledge and skills and understanding that you hope they've acquired and give them questions in unfamiliar contexts, because that will give them the opportunity to extend their skills. Okay, and that's of course what they're likely to be will be tested on in the exam. Okay, there's a question come up in the chat. Can you show the slide on schemes again? Okay, I'd rather not. I'd rather you keep going back over this. I'd rather you go to the website and look up the scheme of work yourself, please, if you don't mind. Okay. I've got a time constraint myself, of course. I've got to finish this by 11 o'clock. So I hope you're not too disappointed that I would prefer not to do that. Okay, moving on to more possible components of a lesson plan. Once you've got to very nearly to the end of your lesson, then have a summary of what has actually taken place during the course of that lesson, to wrap up the discussion and to answer any outstanding questions that your students may not have asked during the course of the lesson. If you're doing practical work, you need to carry out a risk assessment. Students will be tested in Units 3 and Unit 6 on safety precautions, and therefore students need to be made aware there is a section in the students' books on safety precautions and the dangers of using particular chemicals or particular pieces of apparatus, and the procedures that you should carry out to minimize the risk of using that. They need to be aware of certain I'm trying to get the right word. I've forgotten what the word is, but the images. Yeah, I think you know what they mean. The cards, the flame that means that a subject is flammable. That's put on the little symbol that's put on the side of, for example, a bottle containing ethanol. There is a flame one. If it's methanol, there will be one that says poisonous. They need to know those symbols, for example. So if they are told what is the danger involved in using concentrated sulfuric acid, they need to know that concentrated sulfuric acid is corrosive and that you need to wear protective gloves, for example. So another good reason for putting down risk assessments, of course, and the steps needed to minimize them. And then, of course, making sure that your students are aware of that prior to performing an experiment themselves is, of course, it is effectively minimizing the danger that you are placing them in, but it's also a cover for you. So if something does go wrong, you can turn around and say, but here is the risk assessment and the students were made aware of this. If the student didn't follow my instructions that were made clear to them, then I can hardly be held accountable. So it is a good cover for you as well. So it's very, very important to carry out risk assessments. And then at the end of the day, I think it's very, very worthwhile that you go away and think about how did the lesson go. You may wait till the end of a particular topic rather than your lessons and say, well, what's worked and what needs improving. Now, this, of course, is where you will find out, hopefully, as a result of any assessment you carry out on your students as to how well they have understood a particular topic that you taught. And if you find out that then haven't done as well as you would like them to have done, or as well as they should do according to their abilities, then of course you may think to yourself, well, hang on a moment, if they haven't done as well as they should do, and they are very able to do better, then is there something I could do that would improve the way in which I present the information to them that will help them do better? So it's a reflection on your teaching, okay? Always I carry out self-assessment of teaching. Okay, before I move on to the next, which is all about practicals, there's something else come up in the chat box, okay? Right, where can I see safety precautions? There's there are quite a lot of safety precautions written in the student guide, the student books, but there's also information in the lab book, which I will be mentioning later. Okay, where can I see safety precautions? The next thing is, sorry, I missed this. Do they need to know about risks and hazards for all exams? I cannot remember seeing questions set on risk and hazards in anything other than Units 3 and Unit 6. But be prepared that I think they could theoretically be asked for this in Units 1, 2, 4, and 5. But normally it crops up in Units 3 and 6. Okay. Okay. Right, let's have a little bit look about practicals in the exams. But before I do that, we've actually reached halfway through the presentation. Okay, I'm just going to have a 3-minute comfort break in case you need a comfort break. I do actually. It'll give you an opportunity just to get a drink if you need one. It's 10 o'clock UK time, so 3 minutes, 10 past 3, whatever your time is. Okay, please start up again. We'll start up again 3 minutes past 10. Okay, welcome back. I hope you don't mind just having a little 3 minute break, but at the tender age of 73 that I have now reached, sitting down for 2 hours is not really good for my legs. So I needed just to get up and stretch them a little bit. So thank you for your patience. Okay, moving on into the practical work then, discuss a little bit about practical. It's important to recognise that the specification contains 16 core practicals, 8 at AS and 8 at A2. It is strongly recommended that the students complete these core practicals in order to develop the skills that they're going to be tested on in Units 3 and Unit 6, respectively, if they do both the AS and A2 qualifications. Okay. Ideally, the students should do these themselves. It's going to be virtually impossible for them to do them individually unless you've got extensive equipment and chemicals, but they can probably do them in pairs or very, very small groups, no more than 3, so that they can actually develop hands-on experience of this. If that is totally impossible, then of course the next best thing is for you to do this as a demonstration. If that is impossible because you can't get hold of the required equipment or chemicals, then obviously videos are the next best thing. Not ideal, but better than nothing. And to get appropriate videos covering this, I would suggest you go to the Royal Society of Chemistry website and sign up to the teaching section of the website, where it allows you to download the resources that they've got available. Last November, December, I covered for a colleague of mine in Cyprus, in Nicosia, who was on maternity leave, and I was covering her theory work in a room that didn't have any laboratory facilities, so I couldn't do any practicals. And one of the things I had to teach, for example, was recrystallization. So I went onto the Royal Society of Chemistry website and found videos demonstrating the various stages of recrystallization, and was able to show them how the recrystallization was carried out. So though they didn't get hands-on experience of this, at least they could see it demonstrated correctly. So that is an alternative, okay? Bear in mind that the students could be tested on the recall of those core practicals. And all of those core practicals are in fact covered in the lab book, which I will be coming to towards the end of this presentation in the material that's available to support you. Okay, there's a question cropped up here. Please repeat the website where we can get the videos. The Royal Society of Chemistry website. So go into your search engine and type in Royal Society of Chemistry. Okay. I am a member of the Royal Society of Chemistry. In fact, I'm a fellow of the Royal Society of Chemistry. They very kindly recognised the 38 years teaching, and how long have I been training teachers now? 14 years training teachers, and promoted me to fellow of the Royal Society of Chemistry, which I am very humbled by. If you do have the funds, then I strongly recommend you join the Royal Society of Chemistry, because it's a very worthwhile organisation of which to be a member. Okay, now there are lots of other suggested practicals that appear in the specification. They are optional, okay? The reason why we put suggested practicals in the specification is we know that they supplement the core practicals and develop the same type of skills and knowledge that are required in order to be able to answer the questions in Units 3 and Unit 6, but they are optional. I would say the more practical work that you can do, the better. And if you've got tried and tested practicals, ones that you've done in the past, and you know they work and you know they develop the appropriate skills, then incorporate those as well. Okay, the more you do, the better. So you may add or substitute your own practicals too. Going back to the core practicals again, don't be put off if you can't get the exact chemicals required. So, for example, one of the practicals in AS involves using a weak organic acid as a primary standard in titration, a solid organic acid. And if you can't get that solid organic acid, it's not available to you, then of course you could substitute an alternative weak solid organic acid in its place, because the skills developed, the practical will effectively be the same. It's the skills you develop, the techniques you go through, the procedure you follow will be identical. So you can substitute the chemicals. You don't have to use the same chemicals that are actually listed in the core practicals, provided, of course, the procedure doesn't change the procedure, and it doesn't change the skills that the students are developing and the knowledge they're acquiring. Okay. As I said, students will be assessed on practical skills in Units 3 and Unit 6. This will include testing the skills of students in familiar and unfamiliar applications. And I know I've said this already, but I need to stress that the unfamiliar situations, okay? How did I become a member of the Royal Society of Chemistry? I simply went on to the Royal Society of Chemistry website, and there is a little button there that says become a member. You click on become a member and it will guide you through how to become a member. Okay. Students may be asked about planning, including risk management and the selection of apparatus, and with reasons. Okay, so they may be asked to select a suitable apparatus to carry out, let's say, a reflux, or draw that apparatus, or select suitable apparatus to carry out a filtration by under reduced pressure, and perhaps draw that piece of apparatus. They may be asked how to minimize the risk of perform an experiment in which chlorine is produced, in which case they should say chlorine is poisonous and therefore the reaction should be carried out in a fume cupboard or a well-ventilated room. Probably not good enough. I once prepared chlorine in a well-ventilated room and had to evacuate it because the gas didn't get out of the room quickly enough. I should have done it in a fume cupboard. But you live and learn sometimes by your own mistakes, don't you? Luckily, no one got severely damaged. Okay. Other questions may cover data handling, including the use of significant figures, processing data, and plotting graphs. Let me just talk a little bit about significant figures here, because I'm sure I'm going to be asked about that. The chair of examiners rule is very, very simple here. He wants you to use to give your final answer, the candidates to give their final answer to the number of significant figures provided in the data, the minimum number of significant figures provided in the data. So let me give a specific example. Let's imagine there are 3 pieces of numerical data given in the question, and 2 of them are to 4 significant figures, and to 1 of them is to 3 significant figures. he would like the candidates to give their final answer, and I say final answer, to 3 significant figures, for the minimum number of significant figures shown in the data. Okay, he's usually quite generous in allowing 1 significant figure below and 1 above, but he doesn't like answers to 1 significant figure. So that is a no-no as far as he is concerned. Okay, if the question doesn't require significant figures, so there's no, it doesn't stipulate give your answer to the finals, to the appropriate number of significant figures, or it doesn't say give your final answer to X number of significant figures, then they can give the final answer to any number of significant figures that they like. Okay, and he also has another rule, which is no abbreviation until final answer. In other words, the candidates shouldn't round down their numbers in the steps in the calculation until they get to their final answer. So they can quote answers in steps leading up to the final answer to any number of significant figures, even if the question says give your final answer to 3 significant figures or to an appropriate number of significant figures. Okay. Okay, assessing practical skills, Unit 3. I think I mentioned before that Unit 3 is a written practical exam covering the skills and techniques developed during practical work in Units 1 and 2. Okay, the content contains the 8 core practical activities. The examination may include questions where the students apply their knowledges to new practical situations. So the students need to be aware of that. So what they need to do is develop their practical skills by completing a range of different practicals that require a variety of different techniques. And all of those different techniques that are required and will be tested on in Unit 3 are covered in the 8 core practicals, which is why I stressed before that I think it's essential that they have a knowledge of those 8 core practicals. And I didn't say that they have to do the 8 core practicals, because sometimes that may be impossible for some centres, but they have to have a knowledge of those 8 core practicals, okay? Including a recall of the procedures of all 8 of them, because they may be asked about how any one of those is carried out. Okay, Unit 3. Our suggested practicals are included at the end of each topic. I just mentioned that, okay? The points covered in Unit 3 also apply to Unit 6, except the students are expected to develop experimental skills and knowledge and understanding of the necessary techniques by carrying out a range of practicals when they study Units 4 and 5, as well as the test for anions, cations, gases, and organic functional groups from Units 1 and 2. So that is re-emphasising a point that I made right at the very beginning of the presentation. The students need to know that they will be tested, or they could be tested, on the test for inorganic chemistry, the anions and cations, and the gases, and the organic functional groups for 1 and 2, as well as everything from Units 4 and 5. So that would include organic functional groups, alcohols, carbonyls, carboxylic acids, etc. Okay, so what range of support is available to you to help you to plan and deliver this particular course? Well, there's a hell of a lot of online support that's available on the Pearson website, the Pearson qualifications website, okay? That involves the teaching and learning material section that I pointed out to you, okay? It includes past papers, mark schemes, and examination reports. It includes teacher resource packs. There are also published resources, there are student books, and lab books. Okay, I'm going to talk through some of those now. The teaching and learning materials, when you get to the relevant landing page, you will find that there is exemplar material there. Now, that exemplar material there, I think, is available just for AS, but what it contains is a series of student answers that have been marked by an examiner, so that you can see how many marks were given to those student answers. And it's also got a commentary on it to explain why those marks were awarded. Now, that's quite useful to you because it will give you an understanding of how the questions are marked. If you are able to attend tomorrow's session, I will provide you with a lot more examples of that. So I will effectively be going through a large number of exemplar material for you. And I advise you that if you are attending tomorrow's session, make sure that you've got some paper and a pen handy to write down the answers that I give to all of the student responses. Because you may want to use them with members of your department, or you may actually want to use them with your students. I think it's an excellent exercise if you've got the time to get the students to mark these students' work, and they will be on the PDF document that I will include in the resources pack for you tomorrow, and you're quite welcome to use those student responses with your students. Okay. There's a getting starting guide. So if you are totally totally new to the specification, I suggest having a little read of that getting starting guide. Okay. There's teacher mathematics support, which I think is very helpful. So Unit 6 will be practically performed. I'm not sure what you mean by practically performed. No, it's a written paper. Units 3 and Unit 6, everything is written. There is no practical exam in International A-level chemistry for Pearson EdXL. Okay. There's the teacher mathematics support. I'll be talking a little bit more about that in a moment. There is the teacher practical guide, which I'll talk a little bit more about in a moment. There is a transition guide, again, which I'll talk a little bit more about that in a moment. There is past training content. So there is, in fact, a section of past training content where you can look at some of the training that has taken place. I don't think that's in video format, but certainly in PDF format. You can look through and see what was given by me or some of my colleagues. There's the scheme of work, which I mentioned earlier. And there are 2 topic guides. The first topic guide is written by what was a colleague of mine until he passed away, unfortunately, last year, a gentleman called George Pearson, who used to be the chair of examiners for A-level chemistry for Pearson EdXL. He was the chair of examiners when I first started marking A-level papers. And I would say he's probably the best chemist that I ever worked with from the teaching point of view. He was a teacher at Sherborne School in Dorset, which is just down the road from me, from where I live, one of the top independent schools in the country. Well worthwhile reading that document, that topic guide, because it is written by someone I would classify as an expert. Okay. So please have a read of that. I didn't get the teacher practical guide. Instead, we've got the student practical guide, but the teacher practical guide are both the same. No, the student practical guide won't have the answers to the questions in it. Just to confirm, do we need to send our practical skills students have achieved at the end? No. No, you don't have to do that because it's not as the same as UK A-level qualification. So they do not need to send anything off to Pearson's. All practical skills will be assessed by the written exams, Unit 3 and Unit 6. So it's not the same requirements as the UK GCE, okay? Okay. And then there's another topic guide. This topic guide was written by a gentleman called David Reed, who is a lecturer at the University of Southampton. And because there were certain new topics cropping up into instrumental analysis, for example, carbon-13 NMR cropped up for the first stage, we thought it would be worthwhile, given a topic guide to this, to both the instrumental analysis that was on the old specification to what was on the new specification. There are some questions on there as well, which I wrote for this, but the main thing has come from David Reed from the University. Again, well worthwhile reading, okay? Where's the PowerPoint slides? It's in the resource pack, okay? It's in PDF format. So the resource pack, which I think is in the bottom left-hand corner for you to download. Okay, so let's have a little look at each one of these in more detail. First of all, the exemplar material. Marked exemplars with examiners' commentaries. By exemplars, we mean students' responses. And they're real student responses, not made-up student responses. They're only available at the moment for IAS, okay, but well worthwhile reading. The Getting Starting Guide, it provides an overview of this international A-level qualification. It was first written back in 2018, of course, but if you are new to the specification, it is very much applicable to you because it provides information about the content and the assessment and gives you a better understanding of what these mean for both you and your students. So, well worthwhile looking at. The next one is the mathematics, teachers' mathematics support. This covers selected topics that the students find difficult. So, for example, moles calculations, enthalpy changes, reaction rates, including the Arrhenius equation, equilibrium calculations, acid-base equilibrium and pH calculations, and electrode potential calculations. Okay, so there's a wealth of material there on suggestions about how you might like to incorporate particular techniques into your teaching. And again, I have to stress that you must pick out the best practice within this guide. This is applicable to both your teaching style and your students, okay? But there are some very, very good suggestions. The important thing here is to recognize that the teaching of mathematics in chemistry must, no, I said must, should ideally follow the teaching practices that they have in mathematics, in their mathematics lessons. Let me give you an example of why I think this is important. I had been teaching about 30 years. Before, the head of mathematics in the school I was teaching in at the time came to me and said, please could I ask you not to do something when you teach the maths and chemistry? And I said, ask away. And if I can do that, I will do. She said, please do not teach them to rearrange the PV equals nRT equation by taking RT from the right-hand side and pushing it underneath PV in the left-hand side to rearrange the equation to make n the subject. And I said, why not? She said, because it doesn't make any mathematical sense. And I said, okay, you tell me what would make mathematical sense. Divide both sides of the equation by RT. So on the right-hand side, RT cancels, and RT appears on the left-hand side, makes mathematical sense. And I said, I understand. I said, by the way, how did you find out that's what I did? She said, one of your students ratted on you. I said, oh, lovely, thank you. I'm glad she did, I said. I'm glad she did. So that's just one example, I think, because I was doing something that was contradictory to the way in which they were taught in mathematics. And that doesn't do the students any justice at all. They need to be following the same type of teaching. And there's no harm whatsoever in reading this book, because that will have some guidance on how maths is taught. There's also an equivalent guide at International GCSE that also deals with how they're taught the maths at GCSE level. So that's well worth reading if you teach GCSE as well. There's no harm in approaching the maths department and saying, I'm doing these types of calculations, particularly when it involves logarithms, and say, right, they don't need to know the theory of logarithms, but I'm teaching pH equals minus log concentration of hydrogen ions. Any guidance about how in which I should go about doing this? At the end of the day, they will probably turn around and say, well, look, if they're not doing maths, the simple thing to do is simply to teach them which buttons to press on their calculator and the order in which to press them. But there you go. There's no harm. It's just some suggestions for you, okay? The next thing is the teacher practical guide. Now, this is the one that you need to download and read, okay? Because any questions in it has got any questions that are in the student guide, you've got the answers to them. This will support you and your students through all the elements of practical work in the International AS and A-level specification. It explains how the new requirements for practical skills can be developed throughout the course using both core practicals and other specification content. Okay, so again, exceptionally worthwhile to download that document and have a read of it. Okay, the transition guide. Pearson's have carried out a large amount of research, and we know that it's very easy for you as teachers to fall into the trap of going over work that's already been covered extensively at International GCSE. Now, I know I said earlier that teaching chemistry is a scaffolding process, and you need sometimes to go over work and point out essential skills they need to know before you can develop new skills. But you need to keep this to the right amount and not go overboard. This may be the reason why some teachers do go overboard is because of a feeling that during the summer break, students have forgotten what they've been taught. Or if they've come from different centres and different schools, you've got uncertainty about what standard they've actually reached so far. However, the problem is that you can lose valuable teaching time and later find yourself rushed to complete the international A-level content. However, if the students haven't remembered or developed sufficient skills from their GCSE to be able to smoothly go into A-level, then of course they're going to struggle at A-level. So, to help you with the planning and teaching of your first few A-level lessons and to save you time, we have worked out with practicing teachers and examiners to develop these valuable focused transition materials. These will help you reinforce the key concepts from International GCSE and guide your students to progression in IAL. Right, before I go into detail about what this counts, there's some questions coming up. Okay. Okay, no, they don't apply to me, so I'm okay. Right, so here we go. The transition guide includes a mapping of Edexcel International GCSE to this particular qualification, the Pearson Edexcel International A-level chemistry specifications. So you've got a mapping from one to show the progression from GCSE into A-level. You've got baseline assessments, which you can get them to carry out. So that will be assessments on key skills and knowledge that they require before they can successfully access the new material that you're going to teach at A-level. There are some summary sheets in there that are very useful for both you and them. There are some student worksheets that you could give them perhaps to do over the summer break. If you know for certain that they're going to take up International AS or International A-level chemistry when they come back to school after they've done their GCSE, you could give them those worksheets and say, do these over the holidays. Whether they do them or not, of course, is entirely up to them, but at least you provided them with the opportunity to do them. There are lots of practice questions in there, and the teacher version also includes answers for the assessments and worksheets and exam practice. So you can give them the student section, and they can go away and do that work if they want to during the holiday. Okay, I've mentioned the scheme of work. It's broken up into units and topics, so there's greater flexibility for moving topics around to meet your planning needs. Okay, it includes recommended teaching time for the topics, though of course this is adaptable according to individual teaching needs, and of course adaptable to meet the timetable of your particular establishment. And includes a lot of classroom activities, teaching points, and suggested teaching resources. So have a look at the scheme of work and see what is good that you can take out of it. Okay. It's also got a list of objectives for students at the end of each topic, in examples of integrated transferable skills, if you're interested in transferable skills. The objectives, of course, could then be incorporated into your lesson plans. Remember that I said to you that one of the key things of a lesson plan, as far as I'm concerned, is what do you expect your students to understand and know by the end of a particular lesson. Okay, and I emphasize once again what you expect them to know. So what are the objectives? And they're listed in the student guide, so that may actually help you. Okay. Okay, the energetics entropy guide. What is actually in this guide? Well, there are some ideas on how to address the common misconceptions in both the new and previously included content. So the previously included content, of course, is what was in the old specification, and the new is what is in this new specification. Okay. It's intended to help you support this specification and provide some background information to parts of the topic that are actually new from the old specification. If you're not familiar with the specification, then obviously it's intended to provide you with information about this specification in total, both from a teacher's perspective and to ensure clarity of what's expected, and also from a student's perspective when discussing transition from international GCSE or GCSE and addressing misconceptions. This guide can be used as a reference document for you, and parts of it, such as the worked examples, could work as revision material for students. Okay. So besides the ideas to address common misconceptions, you've got possible teaching sequences for key specification points where there is new or challenging content. And you've got the worked examples that I've just mentioned that I said could be used as revision material for the students. Okay, and as I said, it's written by what I consider to be the most important. It was actually the most important chemistry teacher that I actually had dealings with in my career, and I met a lot of very, very good teachers of chemistry. I'm very, very lucky because I did extensive examining work. I was involved in examining from 1984 right the way through to the end of 2017. So 33 years of examining students' exam papers. I was also principal examiner for the international GCSE from 2010 right the way through to the end of 2017. So I did have extensive contact with a lot of very, very experienced chemistry teachers during my both my teaching and my examining work. George Facer was in fact the best of all of them, I've got to say. So please do have a good look at that topic guide. I think you'll find a lot of information there. The other topic guide I mentioned was the instrumental analysis work written by David Reed from the University of Southampton. You've got, again, some ideas on how to address misconceptions. in this particular content, the chemistry content here. You've got possible teaching sequences for the key specification where there's new or challenging content. The new content from the old specification was, of course, carbon-13 NMR. Okay, and again, you've got some worked examples that teachers could use to support students in developing their problem skills. Okay, so again, exactly the same thought process here that for the mathematics guide, you can use it to help support both your teaching and the students' understanding. Okay. There are also in this one some links to external website that can be used to further student understanding. So you might like to have a look at those links and see whether or not you think it would be useful for your students. The teacher resource packs I mentioned, which are an online resource pack, okay. These online resource packs are designed to accompany the student books, and they're available with subscriptions. So although they're online, you do have to actually pay to access these. Okay, what do they contain? Detailed and comprehensive teaching plans for every section of the book. Practice assessments and accompanying mark schemes for every chapter following exam format. Student book answers to the checkpoint and exam practice questions. And practicals support for core practicals includes student worksheets, exam style questions, and teacher and technician notes. So if you happen to have the budget, the money within the budget for your chemistry department, then I would very strongly suggest getting the 2 teacher resource packs. Teacher resource pack 1, which covers AS, and teacher resource pack 2, which covers A2. Okay. Also, the guide to the thinking bigger exercises. If you look at the, I'll come back to that in a moment, okay, when I show you the front covers of the student guides, which I'm about to do so now, because Pearson have published 2 student books to cover the IAS and the IAL courses. Student book 1, and you'll see 3 names there, mine, Jason Murgatroyd, and David Scott. I and Jason Murgatroyd dealt with all the theory work contained within those 2 books. David Scott provided the thinking bigger exercises, and the answers to the thinking bigger exercises are in the teacher resource packs. So if you want to use the thinking bigger exercises and need the answers to those, you'll need to buy the teacher resource packs. Okay. In both of the books, I largely dealt with the physical chemistry sections. Jason dealt with the inorganic and the organic chemistry, though in book 2, there were some extra organic sections that needed to be added from the equivalent books that Jason and I wrote for the UK specification, and those extra organic sections were added by me. There we are. I need to point out that at this stage, there is no requirement for you to use these student books. You can use any student books that you feel are appropriate to your teaching style and your students, okay? These student books have been endorsed by Edexcel, as you can see. They're the Edexcel endorsed books. And the reason why Edexcel have actually endorsed them is because a senior examiner has checked them to make sure that they cover all of the specification content and deal with the teaching the topics in a way in which the answers to questions are going to be examined, are going to be marked in the exams. So other student books may not cover all of the content or may have content in it that's not on the specification. Now, that doesn't mean that you cannot use those student books, but you need to be aware that if it doesn't cover all of the specification, you will need to supplement that with your own notes. And if it covers topics that aren't on the specification, you will need to point out to the students that they do not need to learn those particular topics, okay? But I emphasize once again, there is no requirement to use these two books, okay? It may be worthwhile you getting at least an inspection copy of each book because you can see then how the teaching of these two topics matches the way in which the student responses are going to be marked in the exams. So that is the only suggestion that I've got for you. Okay, please, I would like to know the number of teaching periods for AS and AL chemistry per week during each period. I would direct you to the scheme of work because the scheme of work covers that. And also you'd get even more information if you're able to buy the teacher resource packs. You get a lot of information matching up number of teaching periods for AS and IAL chemistry per week and the duration of each period, okay? So that will give you much more guidance than I can. So student book 1 covers the IS content, student book 2 covers the IA2 content. So student book 1 covers what's needed for units 1 and 2. Student book 2 covers what's needed for units 4 and 5. There's also a lab book. And the lab book, which you can purchase, contains all of the core practicals together with some questions to ask. The students can enter their results and observations directly into the book. Is it worthwhile buying the lab book? Yes, for two reasons. Yeah, well, yes, for one reason, and that is, of course, well, I can think of two reasons. One, you've got everything in one place, and the students are not wondering, where do I put this particular practical into my notes? And when I come to revise for units 3 and unit 6, where are all my practicals? Oh, I'll flick through these now. Oh, I can't remember where I put this one. They're all in one place. Secondly, it does contain some details, some questions that you can ask, and that will supplement the knowledge and skills that and understanding that they develop from doing the practicals. And thirdly, it may prove cheaper to buy the book than to have to photocopy the core practical instructions from the downloads on the Pearson website, photocopy them and hand them out. If you have to pay for photocopying within your department, then buying the lab book may prove to be cheaper. And that's something that you can work out yourself, okay? Right, well, I've come to the end of just about everything that I need to say for the moment. So quite simply, I will ask, actually what I will do before I put that slide up, just let me mention, I'll go back to the question slide in a moment, just let me mention that there's a dedicated subject advisor for you. His name is Tim Lawrence, and you can contact him from teachingscience@pearson.com. Those details are on the International A-Level Specification website, on the chemistry section. They're also on the slide that I have provided for you with regard to in the resource pack. So if you've got any questions at all about this qualification that I've not answered today, not been able to answer, or you need answers to in the future, then just simply email teachingscience@pearson.com and Tim will pick it up and he will either answer it or get one of his team to answer it if he doesn't know the answer. So for example, if it's dealing with examination papers answers, mark schemes, and you're not understanding why a particular answer is given or why a particular answer is not included in a mark scheme, then Tim can contact the relevant senior examiners and they will give an answer for you and get back to you. So you can get all answers about the exam papers, the marks, etc., the way in which it's been marked, you can get by contacting Tim. Okay, right, so there we are. Are there any other questions that you want to ask? I can see a couple here. Does being a participant in this training qualify one to become a certified A-level teacher? Becoming a certified chemistry A-level teacher is something that your school decides. It's up to your principal, head teacher, headmaster, headmistress to decide whether or not you are suitable and qualified to teach A-level. So it's not a question I can answer. I didn't receive any certificate for international modules 1 and 2, as well as the present one. Okay, that's something that is in the hands of Pearson and not me, unfortunately. So hopefully they will get sent out to you eventually. I'm not sure what the delay is. You may contact us via the seat main below. There you are. You've got an email to contact. Okay, so that should sort that out. I have not signed up for tomorrow's module 2. Is there a way I can join the session? I am sending emails to the concerned department, but no response. Okay. Right, Linda, how can you join? The same way in which you join today's. So whatever mechanism you use to join today's, go and online and use that mechanism to join tomorrow's, because it's not oversubscribed, I don't think. So you should be able to join, okay? Okay. Right. Any more questions, please? Certificates will be sent out by email a day after the event. Okay. So I hope to see you tomorrow, Linda. Let's keep fingers crossed that you managed to get signed up. So please feel free to keep asking questions. I'm getting a lot of thank yous. Thank you, Cheryl. Thank you. Very informative. You're very welcome. I'm glad that it was informative. Okay. Are the teacher's resources free for download? Not the teacher resources pack, but all of the teaching and learning resources on the website are free, but not the teacher resources pack. You need to pay for those, unfortunately. But the teaching and learning resources are free of charge. And there's a lot of useful resource materials there. All the ones that I mentioned. Okay. I would like to know the number of teaching periods for AS and IL chemistry per week and duration period. Again, I direct you towards the schemes of work, and also if you can afford them, the teacher resources pack, and you will get details there. It largely depends really on your students and the ability of your students. Are teacher guides available online? The ones in the teacher resources pack are available online. I emphasize the teacher resources pack are paid for. They are available online, but you need to pay for it. How can I participate in marking Pearson Edexcel exams? You can apply through the Pearson website. apply through the Pearson website to become a Pearson examiner? I think they allow non-Q residents, non-UK residents to mark, providing that they have got a UK national insurance number and a UK bank account. But I don't quote me on that. As I said, I think international teachers are allowed to become examiners, providing they've got a UK national insurance number and a UK bank account into which the money can be paid. Please check with Pearson's to find out if that is the case. Don't. Okay. Without further registration, we can join tomorrow's session. I think you need to register for tomorrow's session before you can join it, because you'll need to receive a link in order to log in. Okay. Sorry, I missed the discussion. Sorry, I'm trying to make sense of this. I need to know that to appear of IAL, IAS exams is compulsory. I'm not sure what you mean by IAL exams is compulsory. Okay. Tika, I'm not quite sure what you mean there. So if you can rephrase your question, how to become a Pearson checker? I think you mean examiner. Yes, you have to apply, but as I said, I think you need a UK national insurance number and a UK bank account. Again, please don't quote me on that. That is what I think is the situation. What you could do is you could ask the subject advisor, ask him for advice on this. Okay, so use that email address it's on the slide. Send it in to him and ask him. He will give you exact information. Okay, that'd be the best thing to do. We can't log you in because of an issue with single sign-on. Contact your Salesforce admin for help. Okay. Sorry, I'm not sure what you mean by calculating sign. IS and IAL are both externally assessed. Yes. Yes, they are. All 6 papers are externally assessed. Yes. So there are 3 papers in IAS, units paper 1, 2, and 3, and 3 more papers at IA2, papers 4, 5, and 6, and all 6 of those are externally assessed. There's no internal assessment at all. There's no requirement to send off details of the practical work that they do. Nothing at all. Okay. This is the response that I get once I raise the issue of certificate. Have you used the link that Antoinette gave you earlier? Where was the link? Okay, let me see. I'm scrolling back to see if you can see it. Okay, Antoinette, could you put up the link again that they need to go to get that certificate? That would be helpful. Thanks. Are Pearson Edexcel AS now done in the UK? No, no. Well, state schools, that's government-run schools, cannot do international exams. Private schools can do international exams at GCSE. So the independent schools, the private schools can do international GCSEs, but not, as far as I'm aware, international A levels. I think they have to follow the UK. Okay, we've got another minute left of the time. So any more questions, please? If not, I will end the slideshow and we can all go and get on with the rest of our day.